Hi everyone. In this video, I'll talk about the basics of SQL Server. It is a good video if you're a beginner to SQL Server or just trying to learn SQL Server. I will give an overview of SQL Server. I'll explain what SQL Server Management Studio is. I'll explain the different authentication methods used within SQL Server. Explain the various databases in SQL Server. We will also go through a basic T-SQL statements. SQL Server is a relational database management system developed by Microsoft. It is used for storing, manipulating, and retrieving data. It can be requested by other software applications which run on the same computer or different computer across the network, including the Internet. Database engine is a core component of SQL Server. It is used for storing, processing, and securing data. The other components are integration service, analysis service, and reporting service. Integration service or SSIS is a platform for data integration and workflow applications. It features a data warehousing tool used for data extraction, transformation, and loading. You might have heard of terms like ETL. What it means is extract, transform, and load. This tool may also be used to automate maintenance of SQL Server databases and to update multidimensional cube. Analysis Service or SSAS delivers online analytical processing and data mining functionality. Reporting Service or SSRS provides a full range of ready-to-use tools and services to help you create reports. It is also used for managing reports and deploying reports for your organization. SQL Server Management Studio is an integrated environment for managing SQL infrastructure. It has tools to configure, monitor, and administer various SQL Server instances. It is also a tool for building queries and scripts. Let me show you a quick overview of how SQL Server Management Studio looks like. So if you've installed SQL Server on your machine or laptop, you'll have SQL Server Management Studio. So all you have to do is go to Start and type SSMS and then enter. The Management Studio should open up in a few seconds. Okay, so you can see the server type is set to database engine, and we've already discussed in the previous slide that the four main components of SQL Server are database engine, analysis service, reporting service, and integration service. So let's click on database engine. Server name. I've set up the server name as test LTA, but whatever you've called the server name, you should be able to enter that here. If you have a local server, just put a dot and it should pick up the local server. And then just click on connect. So here you go. You have the Object Explorer. You can see databases, security, server objects. We'll discuss this later in the next slides. SQL Server comes with two kinds of authentication, Windows authentication and mixed mode. Windows authentication is nothing but using your Active Directory Windows credentials. And it disables SQL Server authentication. And if you're using mixed mode, it enables both Windows authentication and SQL Server authentication. The advantage of Windows authentication is you don't have to remember a separate username and password just to connect to SQL Server. Now let's see how to create logins. So creating a login is under security. So expand security and you see logins. Right click on login, click on new login. As you can see, you have SQL authentication or SQL Server authentication, because my SQL Server was set up using mixed mode, hence two options are available. Let's actually select Windows authentication. So you can actually search all the users in your Active Directory. So I've not got any user set up, but if you have any Active Directory, then you can type in your username test1 and then check names, and you should be able to get your Windows user. Let me show you an example to create a login using SQL Server authentication. I'm calling the login name test1. Password. You'll see that all these options are checked by default. It's recommended to leave it checked as it enforces password policy. It also makes sure that you need to change your password once in a while, and it also make sure that the user for whom you're creating the login will have to change the password at next login. So here you go. You can see that a new login has been created. If you right click on it and then go to properties, you can see that it's a SQL Server authentication, and you can also see that all these are actually checked. SQL Server comes with 5 different system databases: master, model, MSDB, resource, and tempdb. MasterDB actually contains the system level information for SQL Server. It stores information about the other databases. Model database, as the name implies, is actually a template database, and when you create a new user database, it actually refers to this model database to create the new user database. MSDB, it's used by SQL Server agent and other SQL Server services. Resource DB, it actually is a hidden system database where all the system objects are stored. TempDB, it holds temporary objects and intermediate result sets of your query. Let's see this on the Object Explorer. If you expand databases, you'll see system databases. And as I mentioned, you can only see 4 system databases. The other one, which is called resource database, is hidden. User database consists of various different database objects. Some of the popular ones are tables, views, stored procedure, and functions. Table is made up of rows, columns, and relations, whereas view is a result set of a stored query on data. It's actually a virtual table. SP or stored procedure is a subroutine available to all your applications. Stored procedure controls the flow. Typically, it can include if, while, loop, repeat, and case statements. Stored procedures can receive variables and it can also return result sets. Functions actually provide a mechanism for extending the functionality of a database. There are 2 types of functions, scalar and table functions. A scalar function returns only a single value, whereas a table function returns a table and it can consist of 0 or more rows. Now let's see a few examples of some of the database objects. Let's create a database now. You can either use the GUI and create database. As you can see, right click on database, you get new database, and then you can create a database here. but it's good to use query if you're a beginner. So let's click on new query. Okay, it opens up a new query where you can type your scripts, which is nothing but T-SQL statements. I'm going to create a database called employee. So the syntax is create database, and this is the name of your database, whatever you want to call it. And then just click on execute. It says command completed successfully. Just refresh your databases, and you'll see that a new database called employee has been created. Now let's create tables. Again, you can either use the GUI or you can use the script. If you expand on tables, you can see that there are no tables here apart from system tables. You can either right click on tables, create a new table where you can actually give your column name, the data type, and you can actually specify if your column can contain or cannot contain nulls. Again, let's use the script instead of using the GUI. I'm going to close this. I'm going to create a table called persons. I've just copied it from a script. So the syntax is again create statement, table, and the name of your table. Okay, DBO is nothing but the schema. So you can actually specify a new schema. I'm not created any schemas here, so by default the schema which is used is DBO. When you're creating objects within the default schema, you don't have to actually specify DBO dot, but it's actually a good practice to specify. So I've created 6 columns here. Person ID is a column name, int is actually the column definition. Identity, I've actually set this column to identity. What it means is, for example, you can have a lot of people with names like John Matthew. Um, so you might want to set up a identity to each of these people. By default, you can actually use identity column where SQL Server will itself create a one-up number for you. So the syntax is C, comma increment. So you actually say from what number you want your integer value to start from and what is the increment. So say for example you create the first user, then the person ID will be set to 1, the next user will be set to 2, and so on. But if you say for example you set the seed to 2, then it starts with 1, and the next person ID will be set to 3 and 5 and 7 and so on. First name Vacha 255. I've set it to not null, but last name not everyone has a last name, so you can set it to null. What this means is when you insert value into the table, if you don't specify a value for last name, it is fine. But if you don't specify a value for first name, then it's not going to like it. I've created other columns called city. Salary is active. It's actually a bit field, and I've set a default value to 1. You don't have to specify it to 1, but by default when you create a new user, it's always active. But then say this person has left the organization, then you actually can update the value of this column to 0, saying that it's no longer active, or you can either delete that particular record. If you want historical data, then you can't retrieve it because the row is obviously deleted. I'm going to execute this query. Right click on tables and refresh. Oh, here you can see that the database is actually set to master. So what it's done is actually gone and created the table in master. This is not what I wanted, so I'm going to delete this. Go back to the query and then select what database you want this table to be in, and then execute the script. Hopefully it should have created this time. Here you go. You can see all the columns. I've not set any key here, but I've set a constraint which is active column. So I've not given a right name, but you can always give a proper name to this constraint. Let's go ahead and insert a few columns. The syntax is insert into the table. You can specify the columns, values. I'm actually inserting 5 rows, as you can see here. You'll also notice that all the keywords are highlighted in blue. I'm going to execute this. Shortcut to execute the query is F5. So I'm just pressing F5 and you can see that 5 rows have been affected. Let's go ahead and select the rows in the table now. The query is select star from the table name. No log. It actually means that you're not going to log the table. Say your application is trying to insert a record. Your query is not going to actually log that particular insert. As you can see here, I've not specified the person ID because you shouldn't be specifying, as SQL Server will automatically create this value for you. 5 rows inserted. Since the seed was 1, it's actually gone up by 1. Let's see how to update a row in a table. The syntax is update, the table name, set again a keyword, is active as a column name. I'm setting it to 0 where person ID equal to 1. As you can see, all the values here are 1. It says that the query has been run. So now let's do a select from the table. As you can see, that row has been updated now. Let's see a delete T-SQL. I'm deleting person ID 2. Note that there is a row, but that's going to be deleted with this. 1 row affected. Again, let's select. You'll see the person ID 2 is now disappeared. The next time you want to insert a record, the person ID will be set to 6 because it always uses the last value of the identity column and adds 1, which is the increment you've defined. Okay, I think we've seen a lot on tables. Let's actually create a view. View, again, as I said, it's actually a virtual object. Okay, the syntax to create view is create view, whatever your view name is, as, and then you define what your view should be. So I've said select first name, last name, city from persons, where active is equal to 1. Since the table also has a history of all the users who are active or not active, um, you can actually define a view so that your application only sees the active users. And then you can make sure that your application is actually referring to this view instead of a table. Else you will have to say select star from the table name where is active equal to 1. So you have to keep using it in all your applications. So if you define a view called active persons, then you know that it's only returning active users. So you know that we have 4 rows in our person table, and one of the user has been set to inactive. So let's select from the view. The syntax is simple. Select star from your view name. Execute the query. Oh, I don't think I've actually created the view. So let me select this and then create the view first, and then do a select from the view. As you can see, it's only returned 3 rows. Now let's see an example of creating a stored procedure. The syntax is create procedure, your procedure name, and then you define what your code should be here. So what I've done is I've actually used a keyword called group by city. What it does is it actually groups your rows. Select from our table 4 rows. We've got 3 people who are from London, 1 person from Leeds. So group by city, what it does is it actually groups these 3 rows, first, second, and the last row. And you need to use an aggregate function. Here I'm using count the person ID. This is one of the aggregate function, and I've called it person count, or you can say sum of salary. I'll call it as aggregate salary. I'm going to run this query. Okay, let's try and execute the stored procedure. Syntax to execute the stored procedure is exec and your stored procedure name. You can see what it's done. So, I think I'll execute these 2 queries here. So, the first result that is obviously from the stored procedure, and the second one is the result set from your second query, which is nothing but selecting all the rows from your table. So you can see there are 3 users from London, so that's what it's done, and it's actually aggregated the salaries. Since there's only 1 person from Leeds, put a count of 1 and the aggregate salary of 45,000. Now let's see how to create a function. The syntax is create function, your function name, you need to put the braces, define what the return type is, as, begin and end, and then within the begin and in, you can actually define your statements. So I've declared a variable here. Anything with the @ symbol is actually a variable. Then what I'm doing is I'm selecting the sum of salary from the table and assigning it to this variable here, and I'm returning this variable. So these are all the rows in our table, so it's going to add up all this and return that. But before that, let's create the function. Created the function. A good thing about the function is you can actually use it like a normal column. Say you're actually doing a select from your table, you're selecting the person ID. What you're doing is salary of the person, you're dividing by the function value and multiplying it by 100 to get your salary percentage. So instead of actually putting the logic every time within your query, you can create a function and then use this function throughout your application. So all your application does is see a simple query, but in the background it's actually calling this function where you've actually returned all your logic. So let's execute this query. So you can see what you've done is you've taken the salary and aggregated it. So you can see person I1 is getting 22% of the salary, 24, 28. So this is how you can actually use functions, and as I said, you can use it in your normal T-SQL statements. With this, I've actually completed the tutorial. I hope you enjoyed it. Um, Please leave comments if you have any questions. And if you like the video, please don't forget to like the video. Thank you.